So 3.6 is over systems of inequalities. So we're looking for points that satisfy two inequalities. And so what does it mean to satisfy an inequality? Well, it means if I plug in the 7 for x and the 4 for the y, we're going to see if that is true. So you don't need your colored pencils just yet. So if I plug in my x and y, I get 4 is greater than or equal to, you need to know these symbols. If I just put the symbol up on the board, you need to know if it's greater than or less than. I have those memorized. 4 is greater than or equal to negative 2 times 7 plus 9. Well, what is negative 2 times 7 plus 9?
Negative 5.
Negative 5. So is 4 greater than or equal to negative 5?
Yes.
Yes. So that means that this point satisfies the inequality. Okay. Part B would be 3 is greater than or equal to negative 2 times negative 1 plus 9. 3 is greater than or equal to 11. Is that true?
No.
No. So that point does not satisfy the inequality. And then part C, negative 5 greater than or equal to negative 2 times 10 plus 9. Negative 11. Is negative 5 greater than or equal to negative 11? Yes, it is. And so the way we're going to do systems of equations is we're going to look at graphs so that we can see all of the points that would satisfy. Like these are just 2 points that satisfy this one inequality. There's infinite number of points. We're going to look for the points that would satisfy 2 inequalities at the same time. And so one thing that you have to know for this graphing is that when we graph the lines, just like normal graphing, there's a couple of extra things that we have to think about. And those things come from these symbols. So the first thing is sometimes we'll draw a solid line like normal, but sometimes it will be a dashed line. So if you look at your symbols, the ones that do not have the equal to part, those are always dashed lines. So when you draw in your line for your graph, you're going to make it dashed. So both of these would be dashed. The ones that do have the equal to part are solid lines, like you're used to drawing. And then we also do some shading, because when I say like y is greater than something, greater than x, it's all of the points greater than. So there's lots of different points. So when we shade, we're saying that all of these points work. And so the shading depends on if it's less than or greater than. If it's less than, we shade below. So we shade under the line. So we'll shade all the graph that's under that line. But if it's greater than, we shade above. This one is a less than, so it's shade below. This is a greater than, shade above. So that's the 2 extra things that we have to pay attention to when we are graphing. Now, unfortunately, these graphs did not copy well, so we're just going to do the best we can, and I need to get you a ruler. All right, so number one, we're going to graph this line. We're going to start at the y-intercept and count based on our slope, just like we're used to. So what is the y-intercept of the first line? -3, which is about right there. And then the slope is -4/3. So we're going to go down 4, right 3. Now before you start drawing a line, I would recommend using a pencil because you're going to be so used to drawing a solid line and it's supposed to be dashed, and if you have an eraser you can go in and erase and make it dashed. So is this line going to be dashed or solid? Yeah. Dashed, because it does not have the equal to part. So we're going to do our first line and then we're going to shade. So take one of your lighter colors if you have a lighter one and really lightly shade above or below? Below. Good. So I'm going to take, here's my line, I'm shading under everywhere under this line. So it does not have to be perfectly colored in. We really don't have time for that. And then we go to our other line. So this yellow right here, every point that I've shaded, if I plug the X and the Y in here, it would be true. And the reason that it's dashed is because these are the points that would make it equal to. And this inequality does not have the equal to spot. So none of those points that are directly on that line would actually fit that inequality. So the second line has a y-intercept of 3 and a slope of 2/3. So you go up to right 3. Dashed or solid? Dashed. Oh, I'm way off. Do I shade above or below? Above. So here's my line everywhere above that line. So everywhere that's in pink will satisfy this second inequality.
Is it like also with the yellow part too?
Yeah. Anywhere above that line. And so there should be a section where your colors overlapped, right? This section right here, this one was above my second line, but it was also below my first line. So that is your final solution, the part where it overlaps. Because these are the points, so take your darkest color and shade it in. Now, if you realize that you don't have a darker color and it's not going to be obvious which one is your solution, then just write an S and have an arrow pointing to it. So that's my solution, which means that any point in this region, and it does extend farther out, is a solution to both of these. So let's look at the point 3, 5. Does the point 3, 5 satisfy this solution or the system?
No.
No. 3, 5 is like over here somewhere. Not even close. So 3, 5 is no. Number 2. Make sure that you graph a line and shade, then graph the other line and shade. Some people want to graph both lines first, and then it's easy to get them mixed up. So finish one whole equation first. So number 2, we start out at -2, and we have a slope of 1. Is this going to be dashed or solid? Solid. And then the other line has a y-intercept of 1. And a slope of -2. Dashed or solid? Oh, wait, what did I miss?
Shade.
After I literally just told you not to do that. So this line right here, I shade how?
Underline.
Under, yeah, because it's less than. And now my second line, dashed or solid? Dashed. Above or below? Above or below?
Above.
Above. This is greater than. So when the lines are steep, it's really easy for people to miss the shading, especially if this line were to be tilted the other way. So if you ever get confused on where to shade, put your colored pencil on your line, and if I'm shading above, go straight up. Straight up. And that shows you where all you need to shade. And then where they overlap is your final solution. So let's think about the point 3, 5. It's probably about right here. Is that a solution to the system? No. It's a solution to the first or the second one, but it's not a solution to both. So, no. My solution is just what's in this shaded region. All right, number 3, we start out on -1. And we have a slope of 1. On the inequalities, we're not looking for a specific point, so you don't have to keep drawing points. It's okay if it's not perfectly precise. Solid or dashed?
Solid.
Good. Above or below? What is it? Above. It's greater than, so it's above. Then I have a y-intercept of 3, which is maybe right there, and a slope of -1. Dashed or solid?
Yeah.
Good. Above or below? Above. And this top section is where they overlap. So one of your questions on the test, I might give you the lines drawn, but without any shading, and I'll give you the equations and ask you which of these 4 regions would your final solution be in. So that's something that you will likely see on the test. And if this was A, B, C, and D, your answer would be A, because that's where the final overlap is. I want you to work on numbers 4 and 5. I did forget to check the point 3,5. So let's go back to number 3. 3,5 would be about right here. So is that going to be a solution to the system?
Yes.
Yes, it is. So number 4, this is what your graph should look like. Your final solution is this side here on the right. Now the 0.35, it's really close. So to somebody that has a really nice graph, can you tell if the 0.35?
It's not.
It's not. That's what I thought, because if you plug in a 3 here, what's half of 3?
1.5.
Okay, 1.5 plus 3 is 4.5. And is 5 less than 4.5? No. So that's how we could check if we weren't sure, if our graph was a little close. It's not. And then number 5, you should have the bottom as your solution. And the 0.35 is definitely not a solution to that system. So when we get to number 6, what do you notice about these 2 lines? They are both dashed. What else? They're parallel. And so, because they both have the same slope. Now, in a normal, just a system of equations, we would know right off that that would be no solution. But on inequalities, sometimes it's no solution, sometimes there is a solution. It all depends on where you shade. So you still have to graph these to see. So my first line starts at -1 and has a slope of -1. And it is dashed. And how do I shade on this one? Below. The other line has a y-intercept of 3 and a slope of -1. And it is dashed. What would make this one have no solution? If this one was shaded above, there would be no overlap. But it's also less than. So we shade below this line. And there is overlap here. It's this bottom section. Work on number 7. Back to number 6. Was 3, 5 a solution? No, it's up here. It's not a solution to any of them. Here's what number 7 should be. So my solution is that dark purple. Is the 0.35 a solution? No. It's up here. And then number 8, the first one is -2, 1, 2, 3, 4, 5, 1, 2. It's a dashed. And I shade below. What about the second line? What kind of line is that? It's a horizontal line that crosses through the y-axis at 3.
Yes. Wait, how many did you go up?
3. Because it crosses through the y-axis at 3, and then it's just straight horizontal. And it's shade above. Here's my solution. This little corner. Ooh. Is 3, 5 a solution?
Yeah.
Yes, it is.
I'm not sure.
It's close. So if you're trying to figure out if it is or not, 5 over 2 times 3 minus 2 is 5.5. And 5 is less than 5.5. So it works barely.